but there's quite a lot written about that. Those sorts of data bias issues. So Joy's work, other people's work, other cases other than face recognition, and also there have been cases recently in New Zealand where people have been misidentified as shoplifters in supermarkets and so forth by these face recognition algorithms, and the difficulties of sort of bias there also have fairly direct implications when you're in a small country, because even if there was a big effort, say in the US, to make a unbiased data set, it would be unbiased for the US. And if you think about how many Maori faces there would be in there, maybe Ted Morrison, so not a lot. So you have all these issues as well. So again, the exam question, in order to make you think about these things, is to talk about that in the case of faces. So Joy's talk's obviously a good starting point there. And then to think about how that would apply to these sort of hand gesture recognitions. And you can talk about what the problems are, how you might go about solving them, whether there's any specific issues which you think do or don't apply in this case that do in that case, and all of that sort of stuff. So that's kind of a less technical question, but a very important question, I think, for us all to think about. That's it from me. Do you want to take a break or just move on to Steffi's bit? It's all the same to me because I'm going to take a break.
I think it would not be too long, so...
Just go for it then. Not too long.
Go for it, early lunch. Yeah. Cool.
Because I actually don't have any slides. So this will, yeah, be a bit exciting because I usually just try to follow slides, but I think it's a very good point to just talk in general what we were doing in terms of the AR part and also sort of the augmented reality part, and also about what could be asked within the exam, and so what to prepare for in particular. So in terms of augmented reality, I think we got like a really good overview, like a general overview about the history of augmented reality, so where everything started back then in the days. So I think what's good to remember there is like the sword of Damocles. So how, in the early days, how people were using these kind of mechanical setups, and also just thinking about the relationship of what we are having today. But so what changed? But what's a bit similar in terms of the concepts there, and. I think what we are, and also we're doing quite a lot, we were looking into the different types of augmented reality. So what is the difference, for instance, between like those head-worn displays, the difference between video see-through and optical see-through. So what are we seeing? What are also the advantages, disadvantages? So we were also talking about basically, like, imagine how you would be immersed within a video see-through head-mounted display where you can't really see your actual environment. What kind of implications does this have? Where you say, okay, I'm just walking along with my video see-through device and I'm not really aware of my actual environment. So if we're, for instance, outside in traffic, what kind of problems could this create? And then in contrast to this, thinking about optical see-through devices where you still basically see what your actual environment is, but then overlaying this with some kind of digital content. And then also we're talking about the differences between more mobile applications, so handheld applications or devices, where you have, for instance, your mobile phone and you're looking onto the screen, then the head-worn devices, then also things like Google Glass, for instance, where you then have like an additional monitor where you are looking up. So there are quite a few differences between different types of devices, and also all of them, they are bringing some different kinds of advantages and disadvantages. So far everyone can still follow with this? Mm-hmm. And you remember roughly what I was talking about, yeah. Then we also had a look into how basically to create augmented reality in terms of actual rendering SDKs, and one of the things that we were looking into detail was the OpenGL rendering pipeline, and how this overall process of starting with a 3D model that you maybe model in some kind of modeling applications like Blender, 3D Studio Max, how you would then put this into some kind of rendering algorithm and bring this to the screen. And there was quite some stuff involved where we were talking about the rendering pipeline, where you put in certain matrices. So we were talking a lot about the model, the view, and the projection metrics. So all of those are basically very much related to a lot of stuff that Steven was talking about before in terms of camera pose estimation, but also the K metrics, like the intrinsic metrics. So how do we use all these kind of parameters in terms of setting up our rendering pipeline? So the actual hardware implementation of bringing this to the screen. And so I think it's really good to remember also in terms of the different algorithms that we were talking about in terms of rendering, using some kind of multi-pass renderings. Like you start, for instance, with rendering something like a video background, and then in the most simplest case, you would just overlay like a 3D model. So this means that you basically just run two rendering passes. One is just rendering like a quad to the screen, and then you're overlaying this with the 3D model, which is including the whole transformation with the model view projection metrics. But then also we were looking into some more advanced rendering techniques, and one of them you were also looking into in the assignment too. So this was about how to, for instance, extract certain elements from the video image, like edges, and then using this in terms of creating some kind of mask effects and creating this kind of X-ray AR view. So there were a certain way of doing this, and also I think what's really important here to remember is really to think about this kind of aspect of visual coherence. So this was one of the main topics of one of our lectures here, where it was really about the idea of how are we combining digital content with our view of the real world. So what is important? And here we were basically talking about, that it's important to really have this kind of coherence, to find a convincing way how to combine virtual information and real information. And we were talking about different ways of doing this. So this was, for instance, this kind of X-ray rendering, but then also we were talking about some kind of occlusion management techniques, where it was more, not so much about having like a artificial X-ray view, but where we were talking about like how can we do some kind of actual occlusion rendering. So if I want to play something behind the table here with a digital model, how can we, for instance, make sure that the user, so maybe you sitting there, you wouldn't see this. So, and here we were talking also in more detail about phantom renderings. Any idea what we would need in this case?
Like some 3D models of like objects, right?
Yeah, exactly. So basically, but if we would like to render like a occlusion, the right occlusion, say from your perspectives, it's really important that we have like a rough representation at least of this table. So in addition to our original input, like the camera model view projection metrics, we would need to have this kind of and the 3D model that we want to render. We would also need to have some kind of representation of the actual environment. And this could be like a table. And I think here it's really important to remember, what is the input for achieving something like this kind of occlusion management, in particular the phantom rendering. What additional input do we need, and how is this then also implemented in terms of the multi-pass rendering, which is a bit different for creating phantom renderings, where we basically really have to also render this kind of occluding object in in an additional rendering path. Would everyone know or remember what was the speciality about phantom rendering in terms of rendering the occluding object?
So you don't mean into the depth buffer.
Yeah.
Right?
Yeah, that's perfect. So I see there's a lot of knowledge in the room. That's good. So that's exactly what you really need to remember. Basically, yeah, you would use the depth buffer. So instead of just rendering everything into the color buffer, which is like the normal output for OpenGL, you would just render this kind of table representation into the depth buffer, and then later on use this in terms of estimating which fragments you actually want to show onto the screen. So basically, all the pics or all the fragments that you would, from your perspective would see, you would just do this kind of depth testing. There's already some content in there because we did like the rendering into the depth buffer before. We're using this for doing the depth testing. It says, okay, there's something in front, don't render, and that's basically how this algorithm would work. So yeah, I would strongly recommend to have a good look into this. But I think I think there's already some good knowledge in the room, which is very helpful. And I think just in terms of the visualization and visual coherence, really, just remember what kind of different algorithms we were discussing here and how they help us also to achieve this kind of visual coherence. So that's important. And then also we were talking quite a lot about different pose estimation and tracking techniques that can be used for augmented reality. So like a lot of the stuff that Steven was talking about before, for instance, SLAM has a lot of applications within robotics. So the camera is moving through a room and then or a robot moving through a room and then trying to estimate their pose, but also the 3D structure of the room. But all these algorithms have a really large potential, and they're getting used quite a lot in augmented reality, because in this case, you don't have a robot, but you have a human that might use like a mobile phone or a head-worn display and is moving through an environment which is very similar to this kind of robotics idea. So they're getting used quite a lot, and I think what's important to remember here is really what kind of different pose estimation algorithms could be used for augmented reality. So we were talking about different methods, for instance like SLAM or other ways of feature-based methods. So there was kind of really huge amount of feature-based methods that we were discussing, but then also there were additional methods. Does anyone remember what other methods we were talking about in addition to the feature-based ones? Maybe with some other kind of input. I used to have time to prepare for this, so it's no problem. But yeah, I think what you should really remember is that there are basically different ways of doing this, achieving the overall goal of pose estimation. And one of them is something like SLAM and feature-based tracking or pose estimation. And then there are like a big bunch of other methods that are using, for instance, 3D models as an input. And we were talking about some of the things that are really simplistic, where you just have like a box model, and then you're just trying to extract the edges from there and doing some kind of alignment with the 3D model and your actual view, so extracting some edges and aligning them. But also we were talking about how to use other more complex models like urban structure. So we talked about this one approach where people were, for instance, using something like a 3D model of an urban street scene, and then using a very similar method where they were extracting the edges and trying to align those edges. And other ways could be also like using some kind of CAD models. So it's really all about when you have methods that are using some kind of 3D models as an input. Those ones are basically these kind of model-based methods. And then we were also talking about this kind of more template or marker-based methods. So would everyone remember roughly what the marker-based methods were about? so you should at least remember one because it is in the assignment.
It's like checkerboard 6.
Yeah, exactly. So the most simple version there is exactly this kind of checkerboard tracking, where you basically have like a template or like a marker. In this case, it's a checkerboard, and you're extracting the corners and using this again, as Stephen explained before, to estimate your pose. As I was saying in the lectures, you wouldn't usually use like checkerboards for doing actual tracking because it's, it requires you to see the overall checkerboard, and there's some more better ways of doing this. For instance, we were talking about the R toolkit markers, and also how they were able to integrate some kind of ID information that lets you place different content on different kinds of markers. So it's then getting more into this direction of application design that really allows you to put different objects into your renderings. And I think also maybe one thing that I would like you to remember is the panoramic mapping and tracking. Would everyone know what I'm talking about if I'm saying panoramic mapping and tracking? Mm-hmm. Roughly? Would you know the difference between like the SLAM systems that Stephen was talking about before and panoramic mapping and tracking?
SLAM is like 3D points, but the panoramic tracking is on the surface, like a sphere surface.
Yeah,
so
yeah,
that's
yeah.
matching putting the imaging, put them together on the surface.
Yeah, yeah. So I think that's a really good point, because like with the with SLAM, like the traditional SLAM, what you would have is like a 3D map representation somewhere, which is really giving you like the full 3D information about all the feature points within your environment. And in contrast, panoramic mapping and tracking is just using like a very simplified representation of your environment, just in terms of making it more efficient. So it really just uses this kind of panoramic map, which doesn't have like the full 3D information. Mm-hmm. It's more something like a 2.5D information, because you know where the feature points are placed within your panoramic representation, but you don't really have the actual distance. Yeah. But you still get some kind of 2.5D information, and that is then later on used in terms of finding basically your orientation in relationship to this panorama. Another difference there, I think I was already giving away a hint here, but so we have like, in contrast to SLAM, we only have 2.5D information, but also what is the difference in terms of the output that we get for the tracking or pose estimation?
Basically, that's orientation, right?
Yeah, exactly. Yeah.
Like this one.
Yeah, exactly. So it just gives you the orientation back, so there's no information about the actual translation. And I think that's really important to remember here. But it's basically a really good way in terms of making your computation more efficient. So this was basically one of the approaches that was used very early, also for providing augmented reality on mobile phones, when the computational power was not that big. And it could also be helpful for certain applications where you can't do like a full triangulation. So for instance, like with SLAM, usually what happens in the first frame is you really need to have this kind of baseline, so between the different frames. So this means with a lot of the SLAM systems, what would happen is, at least if you don't have some kind of depth sensors there, what would happen is that you really need to do like a translational movement. So some of them they even tell you. So for instance, if you do some of the AR apps on the phones, sometimes they tell you that you should just scan the room a bit more. And so this means like what you want to have is like a good baseline, because this is the input for creating some kind of triangulation and then creating the 3D map with SLAM. And the problem is, if we're now talking about some of the augmented reality applications, in particular outdoors, people often have the tendency that they're searching for some information. Let's assume that we're talking about some kind of touristic sightseeing applications. They would search for a certain point of interest, then they would stop and just browse around. So this means there is not so much translation going on. So people are usually not really using AI applications as it is on the mobile screen and walking around like this, because it's kind of also a bit dangerous, in particular outdoors. So this means like one of the advantages of this kind of panoramic approaches is also that you don't need the right baseline. So you're just getting the orientation information back, but it also just means that you don't have to do this kind of actual translation and movement, which is also a good good aspect or good advantage here. Okay, and then I think also we're talking quite a lot about the about all this kind of visual coherence, and I think also there I was diving a bit into this aspect of perception and perceptual issues, and I think what I would like you to remember there as well is really getting a good understanding what is important for the human visual system in terms of understanding the spatial arrangements around us. So what are we using? What are, for instance, visual cues? What is occlusion doing? What are shadows? What other information are we using in terms of estimating where objects are placed in relationship to each other? I hope I didn't create too many question marks now. So are you mostly okay with these kind of topics? So, or do you think you would need some kind of additional input there? Or I don't know, if you have any more questions, then just let me know, and I can also just explain some stuff more in detail. Or do you feel kind of confident with these kind of topics? Not too bad.
I think I'll feel better after I've studied a bit.
Yeah. So I mean, I think that the main goal I think for this lecture was really giving you a bit of a hint what kind of topics could be important for the exam. But I think also it's really a good idea to have a look into the previous exams, because this really gives you some good preparation. And I think if you can answer the questions that are in the previous exams, then that should be fine, but also don't be too worried, as Stephen was saying before. Some of the topics were not covered this year, so if there's something they don't really know what's going on, then either let us ask us or just have a look. We were talking about this.
But even those ones we didn't know the sort of style of question.
Yeah. Cool. So I think this was mostly it from my side. And
Yes, that's mostly it from us.
But I mean, if you want to discuss anything more in detail, or have some specific questions, you're also happy to answer those.
So I don't think either of us is travelling the next couple of weeks.
No, I'm really happy that I don't have to travel this week.
Which means that we should be around if you've got questions.
Yeah.
Cool.
And I think also since everyone was doing the assignments, I think also the assignments give you some really good background of basically what's important for this paper. So just having this kind of practical aspects as well, I think that's really helpful. Okay, cool. Then was a lot of fun teaching the paper, I think. So I hope you also enjoyed the topics, and if you have any any feedback, or if you think there's something that you think maybe this could need some more material, then also let us know, because I think we are always also interested in improving the material. Cool.